Let's answer some questions here. What do we got? Yes? Yeah. Should be. Just go same place you found the other part. Should be page 1 and page 2. What do you think we're doing now? All right, now. There is one question, question 22, which is different on the answer key. We realized there was a mistake on the original review sheet. The answer to this one had a 2 pi over 3. Now, can you tell me where in the circle you have a sine of 2 pi over 3? Well, sine inverse. Sine inverse gives me, what's the range of the sine inverse? What's the range of the sine inverse? Negative pi over 2 to pi over 2. That's right. Remember how we did that whole restrict the domain of the sine function so that its inverse would be a function? We had that whole big long video. Okay, in fact, it was in multiple pieces that you have watched frequently in your spare time. The range of that would not, is pi over 3 in this range? I'm pretty sure pi over 3 is inside there. But on the old answer key, it had a 2 pi over 3. Is 2 pi over 3 in there? No, which is why the old answer key says that this question had no answer. But since the question has been modified, there is an answer. So we might want to do this one together. All right. Can you find all the places on the circle that have the exact same y value as pi over 3? Can you find any angle that has the exact same y value? Now, why did I say a y value? Because we're talking about sine, right? So we know that pi over 3, yeah, roughly there. Can you name every single measurement on that circle that has pi over 3 as an angle? That has pi over the same y value as pi over 3. No. Okay, now, how many people would guess that pi over 3 has the exact same y value as pi over 3? I'm hoping you all say that. That's true. Right? Pi over 3 has to have the same y value as pi over 3, right? But is there another? Come on, in the words of Yoda, there definitely is another. Where in the world is there another angle measurement that has the exact same y value? Hey, 2 pi over 3. Good job. Those two have the same y value, don't they? And we all know that's radical 3 over 2, but we don't even care that it's radical 3 over 2. We were being asked for every single angle measurement on the circle that has that same y value as pi over 3. Okay, so that would be a correction on your answer key since the problem changed. Okay. So, as you were going over this in the weekend, what else did you come up with that you want to go over? Yes, 26. How many of us know that x is a secret way of saying x over 1? Everybody know that? X over 1 are the same? You probably need to draw a triangle, a right triangle. Not a wrong one, but a right one. And give me which two sides I just handed you. It's cosine, that's adjacent hypotenuse, right? So which one is x and which one is 1? The hypotenuse is 1, right? Theta is down here, folks, for those of you wondering. The horizontal one. That is extremely critical that you be able to put those two sides on the triangle in the correct spots.
Where do you decide where theta is?
Okay? Theta is always in the bottom left. We just always put it in the bottom left. So this right here represents theta. Okay? But for argument's sake, we just make it the bottom left, and then you'll never, there's no way to screw it up if you just always make it the bottom left. Okay, now, what would this one be? What would the upright side there, the vertical side, be? 1 squared, commonly referred to on the street as 1, minus x squared. Sorry, it's bad with the square. Alright, now they ask me for cosecant. Cosecant, that's the cho, right? Choshikau. So, what do we have? 1 over radical. Now, I don't care about rationalizing this because that would be a huge waste of my time right now. Right? What I'm trying to go after here, folks, is do you understand what cosine is? Do you understand how to make the triangle? Do you understand what cosecant is? Rationalizing is not on my radar for this question, folks. Okay? So don't waste your time with rationalizing. Move on. Plenty of other things to do here. Okay, next. General question.
What are you looking for in numbers like 1.4? Are you looking for angle measure?
Okay, first of all, every inverse function. Inverse functions are always asking for angle measurements. That's what an inverse function is. In question 4 right there, did I give you an x value, or did I give you a y value, or did I give you a slope? I gave you a y value. I'm asking you for the angle measurement now. Before I answer question 4, I need some blank space here. There's a good blank space. What's the square root of 9? 3, right? Solve this equation. If you say 3, you're only half right. The question on the right is a solving question. The question on the left is a simplifying question. Do you see that they're different? Question 4 that she just asked me about, is question 4 a simplifying question or a solving question? It's a simplifying question. There's only going to be one answer. So, the range of the inverse sine, remember the range of the inverse sine went from negative pi over 2 to pi over 2. So, you said that that was a y value. The y value is negative radical 3. That's the one that's close to the bottom edge of the circle, but not at the bottom. And if it has to be between negative pi over 2 and pi over 2, it's got to be this one right here. So what's my answer? It can only be one of these choices, folks, because these are the only ones in the sine inverse range. Okay, now don't tell me degrees, for one. And your answer better be between negative pi over 2, that's this one down here at the bottom, negative pi over 2, and pi over 2. So if you start quoting me 5 pi over 3, you are not in the range. I'll give you a hint, it's negative pi over 3. as I said in the video, I listed out on the unit circle all the ones that were the answers that you could choose from. These are like giant multiple choice questions with, what, 12 answers or so? Sine inverse, obviously, is only the right half of the circle. Those are the only green dots you can choose from. All right? Can I what? I give you a unit circle, just like you got before on the quiz. So you'll have a unit circle with the nice dots on it, and then it's not a question, so it's not going to be graded, but it'll be there for you to use, so that you don't have to kind of guess and draw your own circle and get ugly circles like mine. You'll have a nice circle to use. That is not the same. I'll get to you in a second. That's not the same thing as question 24. Is this a simplifying question or a solving question? This is a solving question. So when you subtract 1 and then divide by 2, right? You're going to do all that. And you're going to come up with cosine x equals negative 1 over 2. You're being asked for every single value on this circle that has the exact same x value. What x value, and how do I know I'm dealing with an x value? Because it's cosine. Well, if the x value is negative 1/2, that's over on that side, then there's two answers. One there, and one here. Because last period they asked me, well, why doesn't it go with the range of the inverse cosine function? Well, I understand what you're getting at, but that goes back to simplifying versus solving. Simplifying, you're right, would have one answer. Solving in this case, has two answers. What is one of those answers? 2 pi over 3, right? That's that one right there. And 4 pi over 3. Yep. Okay. Different type of questions? Somebody else had a hand up? Sure. Question 5. Is that an x value, a y value, or a slope? That's an x value? Okay. This is a simplifying question. We have been given an x value. I'll choose a different color. An x value of negative radical 3 over 2, so the one way out by the outside edge of the circle. Cosine inverse. What's the range of the inverse cosine function? Okay. Might want to watch those videos tonight. So we got 0. These are the only choices that you have for the range of the inverse cosine function. So, come on, choose a different color. So I'm guessing that has to be the answer right there, because it's inside the range of the inverse cosine function. So what is that one right there? 5 pi over 6. What else would you like to go over? Do you know why number 14 is impossible? Do you know why? What's the largest sine value you can think of? 1, right? So you can't have a y value of 1.2 on the unit circle. So I had another student ask me about 16 last period. Can you have a slope that's bigger than 1? Amen. The graph goes on forever and ever and ever, so I'm pretty sure you can have a slope that's steeper than 1. Slope. It's not an x value or a y value, it's a slope. So, what does tangent ask for? Is tangent asking me for an angle or a slope? Slope. We want to know what the slope is, and then the angle has a slope of 5. What slope of an angle that has a slope of 5? If you listen to what I'm saying, it's a pretty easy answer. Don't make it more difficult than it is. Give me a slope for an angle that has a slope of 5. Nice job. See, in other words, they canceled each other out. None of you is going to know what that angle is. Now, if I had a calculator, sure, I could type tangent inverse 5 on a calculator. But I'm going to turn around and hit the tangent button. Guess what it's going to give me? 5. You know, that's not like this question, 17. Figure out this part in here. What's the cosine of 5 pi over 6? What's the cosine of 5 pi over 6? So this question is sine inverse negative radical 3 over 2. Okay. What is the sine inverse of radical 3 over 2? Well, it really depends on whether you know the range of the inverse sine. Hopefully you're going to choose something on the right half of the circle. Negative radical 3 over 2. Is that an x value, a y value, or a slope? It's a y value. So I'm guessing my answer has to be right about there. What angle measurement has that y value on the right half of the circle? Don't tell me 5 pi over 3. Negative pi over 3, that is true. Okay. Notice that they've mixed the two. It's a good question you're asking me, but they have mixed the two. So they first said find an x value. So we found an x value right there. But because they're changing it and asking for sine inverse, I have to now use that as a y value. That's you know, I understand it's a tad bit on the tricky side when they started out with an angle, asked me for x, and then they changed it up on me and said, now use it as a y and find my angle measurement. That's a little bit of an evil trick. I do understand what you're getting at there. But that's why I said in the notes, start on the inside and work your way out. All right, what else? 19? 19, we need a triangle, don't we? A right triangle. Not a left, but a right. Which side on that triangle, since cosine, that's adjacent hypotenuse, which side is 1 and which side is 5? The bottom, alright, so yeah, you got a 1 right there. Where's the 5? Hypotenuse. So what does that mean for the right side there? 25 minus 1. Alright, so we'll call it radical 24. And then they wanted to know what? They wanted to know opposite over hypotenuse, didn't they? They wanted to know the sine. What's the opposite? Radical 24 over 5. circle, but not including the endpoints. So everything on this half, but not including the endpoints because of that whole undefined slope at the top and bottom. So we're looking for an angle measurement on the right half of the circle. We know the... Ooh, why did I put a bracket? Seriously, I can't do that. We have to be between negative pi over 2 and pi over 2 according to the restrictions we did in our notes. Have to be between those two, and has to have a slope of negative radical 3. Has to be fairly steep, right? It's got to be steeper than negative 1. Negative pi over 3, good call. We've had a lot of negative pi over 3s. Don't say when in doubt, negative pi over 3. Okay, that's like the dumb, when in doubt, the domain is all reals. Okay, seriously, that's ridiculous.
That's what I do.
Yeah, I know.
I just have to ask. Yeah, it normally works.
Okay, don't be in doubt then. Don't go there.
You're always
No.
I don't
Okay, next. Yes, I'm sure you are. We all are. What else? 21? So should you. Okay, so how can we get rid of cosine? How do we get rid of cosine? Hold on, we'll get to your right, but how can we get rid of cosine? Cosine inverse, yeah. But if you do it to that side, you better do it to the other side too. And then what happens? What happens to the part in the green box? Let's see, if only we knew what x was. Yes, in the calculator. It says without a calculator.
If I just put a line through the cosine, like inverse cosine.
They do
cosine,
cancel out. They do. I mean, you can look at it that way as well. You can. So several of you were giving me that idea in the beginning that these two cancel out. Part of that is because of the range of the inverse cosine function, but yeah, you're okay. You're okay. We're not trying to be nasty, tricky with that. The ones that you have to pay attention to are when the inverse sine function or inverse cosine is on the outside first. That's where you got to pay attention. Like 22 had 2 answers, where 21 only had 1. Okay, I love this question because kids are always like, but I don't know where 3 pi over 10 is. Okay, guess what? It's okay, folks. You can kind of guess. It's really not that bad. Okay. Do you know where 5 pi over 10 is? I mean, I'll give you a hint. This is 0. This is 10 pi over 10. Where is 5 pi over 10? Why is this short circuit? The very top would be your 5 pi over 10. So which quadrant would you put 3 pi over 10? Hopefully you'd put it in the first one, right? Kids are like, but I don't know where it is. Well, let's see. 1, 2, 3, 4. Okay, so yeah, I'm kind of estimating. It's got to be past the halfway mark. It's 54 degrees for those of you panicking. Okay? But who cares? Okay, so we're asking for every value, every place on the circle that has the exact same slope as 3 pi over 10. Can you give me one of them? 3 pi over 10, nice job. But guess what? There's another one. It's down this way. Now, where'd you get 13 pi over 10? right, you just added pi, which is 10 pi over 10. So if you take 3 pi over 10 and you add 10 pi over 10, it's 13 pi over 10. And last period was complaining about that. I did the fractions. I don't think they like fractions. Math teachers.
Very small.
Well, thank you. I'm trying to lose weight. Alright, next question. What else you got on this cool worksheet that you've been looking at, reviewing all weekend? Yes? Okay. Simplifying is you don't have to find. It's not like I have to undo something. Like when I ask you for the square root of 9, you're just looking for that value. It's not like I have to do something to both sides of an equation. When you're solving, you have to do something, or even multiple steps, to get x by itself, so to speak. Okay? That's why there's a big difference between question 24 and, the 4, 5, 6 questions. Because those 4, 5, 6 questions are simplifying questions, whereas 24 was, find me all the values that make this sentence true. Got any more? What else? 34. Let's put it in fireproof form just for... Oh, and as I talked about before last week, because somebody asked me about it, I think it was back here in the corner. As I said last week, because I think Ms. Richmond asked me about the bearing question, we're saving that one for the vector chapter. We're not there. Okay, so 34. So let's put it in fireproof form just for fun here. Y minus what? 72 over what? Equals the sine. Now, the question we have here is what do we put inside here in the numerator? So we'd have pi over 8t minus pi over 2 all divided by 1. What are we going to multiply the top and bottom by so we can get 1t? Well, we're going to multiply by 8 over pi, right? And we'll do that to the top and the bottom. Well, yeah, but we still have to distribute it to that too. Yes, the basis of my decision was what would make the t have a coefficient of 1. That is true. So now I have t minus what? What? Close. How about just plain old 4? Because the pi's cancel. Yes, there we go. Okay. And on the bottom, 8 over pi, right? What's the period of the function? If we know that it's 2 pi times a, and a is 8 over pi, what is the period? 16 seconds. It takes 16 seconds to make one trip. Now, before we go too much farther into, I guess we could do A. How long does it take her to do 2 revolutions? 32 seconds, right? You just doubled it, right? What's the radius of the Ferris wheel? Radius of the Ferris wheel. Remember we talked about Last week when we graphed this stuff, we said that we had a center line to the wave, that was K, and in this case, what's the center line of our wave? You had it written down somewhere, right? $72, okay? What's the amplitude? The amplitude was 70, right? So that means it goes up to a high of 142 and a low of 2. The radius of the wheel is the amplitude, right? These go together. All right, cool. So it's the radius. Right. Nice. That's what we talked about last week. You can watch that in the video. What is the radius of a Ferris wheel? And it is 70. Now, we have a radius of 70. What is the circumference? Just, can you figure out the circumference for me? Take a calculator. 140 pi. How many feet is this? 140 pi. 140 pi. How many feet is that? 439.8 feet. 439.8 feet. Okay, now, how many seconds does it take to go around? 16 seconds. Remember, 32 was for 2 revolutions. Right? So you are going almost 27 and a half feet every second. I'm thinking I'm going to be vomiting here, alright? So, you better be strapped into this Ferris wheel. This is cruising, man. It's pretty good. It's pretty good for a Ferris wheel. I don't know. Maybe I'm wrong. Okay? Usually you want like a gradual ride, not. Okay, how high above the ground is she at 0 seconds? Okay, so. Okay. But for a Ferris wheel, same. I mean, like, I understand. Plus, you're going, through this, so it might be, I don't know. Maybe it's better than I think. I have to check that out. What do I do with the 0 seconds? Where do I put the 0 seconds? T, the time, yes. I'm pretty sure you would grab a calculator. Which mode should your calculator be in? Okay, look at these pies and tell me which mode you think we should be in. Ooh, Radian Mode. Okay, I'm pretty sure you're going to be good at typing on a calculator. You might want to take it slow, instead of trying to type everything in. Does it matter if I use the equation that I was given originally? Could I use this one right here? Yeah, sure I could. And it's actually kind of smart because, it's already solved for h. So, that's not a bad idea at all. And then, of course, for 4 seconds, you'd plug in a 4. Oh yeah, you have to do exactly what you see in the equation. In fact, if I plug in a 0, I end up, if I go through that process, I end up with 2 feet off the ground. What does that mean? Where did I start when the clock started when the clock started for the official ride time? Where was I at the wave? Now, don't sit there and say, well, you were at the bottom. I get it that you are at the bottom this time, but it doesn't necessarily mean you're always. Remember, we did this before. We didn't start at the bottom. We were like 73.3 feet off the ground. All right? Because you start at different spots on the Ferris wheel. Only one person starts at the bottom. Maybe 2 if it's big enough, which is normally a big number of people. Since that's the whole point of the Ferris wheel. Never mind. Okay. I digress. So it's going to do this kind of thing, right? It's going to reach a maximum point. How long did it take to get to here? How long did it take, sorry, maybe I should be more specific. How long did it take to get to this spot right here, where you're at the center line of the wave? 4 seconds. Now, where in the equation did that kind of come from? That would be helpful, because remember on the sine wave, the HK value sits on the center line of the wave on the way up the hill. See, we've done all this before, okay? So, when does it reach the middle? At 8 seconds, that's true. 8 seconds, you would be at the top. Now remember, when you watch the video for the other Ferris wheel, it was a cosine wave. And since h sits under the max, I had already basically handed you the time it took to reach the top. This one, you actually had to think about when you reached the top. The other one was kind of gifted to you. Assuming you can do algebra with that trick with the Miss Myers was talking about, where we flip the value for the coefficient of the t. Okay. How many feet? Yeah, I saw that look. I saw that look too. How many feet will she travel in 64 seconds? Okay, now if it takes 16 seconds to go around once, how many times have you gone around in 64 seconds? So that's 4 revolutions, right? And we figured out that 140 pi was the circumference of 1 revolution. So wouldn't you multiply that times 4 to figure out the number of feet that she traveled in 64 seconds? Probably won't ask that question, but that's a really cool question. I like it. Give the time when she reaches her max height. We already talked about that. That was 8 seconds. What else? Huh? Include that question for extra points. What else? On 35, make sure you go back to the video and watch how we did all that, because, obviously there's a lot of stuff there. But question 7. All right, so we know that tangent inverse, the range of the inverse tangent, right, that goes from negative pi over 2, not including negative pi over 2, to positive pi over 2. So the right half of the circle, not including the endpoints. At least that's what we discussed. So, is this an x value, a y value, or a slope? That's a slope, right? Negative radical 3 over 3, that would be this kind of shallow one. Which quadrant should I be in based upon this stuff right here? Right down here. That's the only one that applies, since this is a simplifying question. It's not the same question as this one, Miss Bushman. This question, sorry, I wrote that backwards. This question would be the one you were asking me about in terms of solving, because this question has 2 answers, but the one we're dealing with right now has 1 answer. What is the answer to my question where that big green dot is? I'll give you a hint. It's negative. Negative pi over 6 is the correct answer. See, it wasn't negative pi over 3. Guess that one, you'd be wrong.
But we weren't in doubt that time.
That's good. That's good. I hope you will not be. Good. Oh, I didn't mean to do that.